Hello, in this video, I'm going to show you how to publish a Python package on conda-forge. In the previous lectures, we have covered how to publish a package, Python package on PyPI. So if you see this, our package here, so right now we have 0.06, and if you click the link, it should be able to open and navigate to the website. So PyPI is basically the Python package index, and it has a lot of Python packages. If you can see, here right now it has 532,000 projects. So, and anyone can publish a Python package here, and there's no really quality control. So you can, as long as you have an account, you can upload your Python package to here and then publish. On the other hand, we also have the so-called conda-forge. So this is another community maintained package repository. And if you can come to here, how many, over 22,000. So this is only, I would say, 5% of the Python package that available through conda-forge. So this one is quality control. PyPI is not really. So there are some scammers actually have some malicious Python package that install on people's computer and then steal information. But in general, this is a large repository. Certainly, if you want to publish a Python package, you want to publish here, and at the same time, also in here. And the reason why we have two, because this one is using conda, and conda is a Python package manager that allows you to install Python packages and make sure that they are compatible. And the other thing, advantage is that you can install package that has already been compiled. So basically binary packages. So this is a blog post showing you the differences between the two of them. You can just Google, for example, why conda is better than pip. And so here it's kind of summary. So conda can install binary packages, means that the package already include the compiled source code. Compared to PyPI, pip is compiling the source code when it's installing. So this sometimes can take a while, especially if your Python package has a lot of dependencies and other stuff, and sometimes it might not work in all cases. And this is especially true for geospatial Python packages, for example, GDAL. If you're trying to install using pip, sometimes it's going to run into issues because it uses some C++ and C even, and it's very challenging to install on some computers. On the other hand, conda is already compiled, so it's actually so much faster and easier. And also it can make sure that all the dependencies are compatible with each other. So in general, if you want to publish Python package, you want to have them on both. So in this tutorial, I'm going to show you how to publish Python package on conda-forge, and so that you can make it more widely accessible, and so you can easily integrate into other Python packages as a dependency. So in order to do that, let me show you. First, you can search, for example, come here, packages, and right now we have almost 24,000 here. So any packages that available on conda-forge, you can search here. You can try, for example, leaf map. So this is the package that I created and published. And once you open, it's going to show you the instruction and all the information here. And this is in general how we install the Python package through the conda-forge channel. You can also see how many 123,000 downloads, and you can also see the history. So I published this one probably a couple years ago, around three years ago. So you can go all the way to the end, 3 years and 1 month ago, 0.01. And certainly you can do that as well, but you want to wait until your Python package is mature with a lot of functionality that will be useful for other people. And so far in this course, we have been building, but the functionality you are having right now probably is still very limited. So I'm going to show you how to do that, but I don't recommend that you try to publish this one right now because it's going to take a lot of resources. In the previous year, because I teach people how to publish, and then a lot of people submit the pull request, and then kind of the maintainers are overwhelming, so they don't recommend that. Reach out to me, ask me not to do that. But I'm just going to show you the step when you are ready to publish one in the future. You know how to do that. Okay. So next, I'm going to show you how to do that. You can certainly come to the community here, and then show you, for example, how to publish the package. But there's let me show you here documentation, and I'm not sure if there's one here. Update package add recipe. So if you come to the condaforge.org, and here's going to show you how to add a recipe. And this is where it's actually you need to submit a pull request. Okay, and I'm going to show you step by step how to do that. The first one is you need to log into your GitHub account. So if you log in and make sure that you sign into your account. So because I have two-factor authentication, so you can ask me to log in. Once you sign up, the first step you need to do is to fork this repo. Also, there's instruction here step by step showing how to do that. We're going to install the Grayscale package, and then after that we're going to basically generate the so-called recipe. So the recipe you can think about is the recipe that used to create the conda-forge package. So basically what kind of dependencies there, and then what kind of requirements is all going to specify in the recipe. So again, first step, fork the repo to your account, and then just say create a fork. And this is going to take a while because this repo is actually pretty big. There are tens of thousands of commits, actually 128,000 commits, so it's a lot. And once you finish this one, the next step is to clone this one to your computer. So just click this button and then copy. Then you can come to wherever you want to clone to your repo. So I'm going to do it in here, right click, and then open terminal here. Then you can just type git clone, hit enter. So you should pull this one to your computer. And once it's done, then we can start. I can show you here, or it's not finished yet. It's going to copy the entire repository. And what the step we need to do is to come here, put our recipe within here under the recipes directory, and then submit a pull request. All right, so it's done. And if you come here, recipe, take a look at this one. So right now there's an example recipe in here. You can open the entire repo using Visual Studio Code, and this is a recommended way to make changes. And then you can come here, recipe. This one shows you kind of all the available, basically different components of the recipe. So from, for example, where is it coming from? What's the name of the package? What's the version? And also where's the source code? How to build the package, and what kind of dependency requirements, and how to do the testing about something like that. And it's kind of overwhelming, but there's an easier way that you can do that. So if you come back to the instruction here on the home page of this repository, it's going to show you here you can generate so-called recipe generator for Python package, and it's using the one called Grayscale. And you can install the package, then we can just use the Grayscale to do that. So here you can use conda-forge to install the package, or you can just use a pip. And from here, I'm just going to conda activate geo. Then you can just pip install Grayscale, hit enter. All right, so you see it's done. Once it's done, then I can get into my repository in here in the recipe directory, and I'm going to open my terminal here because I'm going to generate the recipe and then put it inside this recipes directory. And what we need to do is just Grayscale, SQL, or you need to conda activate it first. Conda activate geo, and then Grayscale PI. So it's basically going to get the package from PyPI, and then the name of the package. So for me, I'm going to basically generate the package for the geo head. So this is the one that I have been building for the whole semester. So just hit enter, and within a few seconds you should have that. So hopefully there's no any error message. If they see any red color, then you have to fix that. That means some of the dependencies are not available. If it's all green, that means you are good to go. So it looks pretty good. Then let me open the directory here. As you can see, now the package is available here as a recipe. Then we can open using VS Code to take a look at that. And so it shows you all the information here. This is the version and the source code, build number, so non-arc. So most of the Python package is pretty simple. If there's no specific requirement on, it works on all operating systems, so it's going to be no architecture. So this is basically the recommended way. You should try to avoid using operating system specific Python version. So here we're just using because it works on Linux, on Mac, and Windows. And the host basically is what kind of environment that is required. They need to build the package. And this is where actually the dependency. So this is automatically retrieved from the Python package that we have been building. So if you go to our GitHub repository here, look at the requirements.txt. So this is actually where those packages. Oh, I haven't published a new version yet. So this is an older version. So that's why it's a bit different. But that's okay. We can update it later. But now this is what it is. And also the about section. So you can keep them, all of them. But I think you need to have a home page. That one is a requirement. So that one doesn't show up in here. So I can just type home and then colon. Then you can type in the home page to your package. So for me, I'm going to use this one, gshub.org, and paste here. Also, there's another one you can do is I think it's dev URL. So this one in general is basically the your GitHub repository. So in that way, when people go to the link, they can find out the information. And this is where if you see the leaf map repository, go to the home page in here, it's going to show you the home, the development, and also documentation. So these two are basically the same. You can use whatever home page that you want, but at least you want to provide some URL. And there's also a description, for example, here allows you to give a description. So I think the description, I can just copy this one from GitHub, okay, and then come here. From this one, summary, you can have a description, colon, paste, enter, Control H. Pretty much that's it. So once you have this one, then your recipe, I think, is ready to go. So what we can do here is open the terminal. And then we can create a new create a new branch. And so the branch name, git checkout-b, geohe. So basically the package we're going to create, hit enter, and then just push this one to GitHub. So we can say add geohe package, Control enter, and then publish origin. All right, so it should be on the GitHub now, and then we can open the branch so we can take a look. So here, this is where it is right now. So we're under the geohe branch, and we can submit a pull request. So just click compare and pull request, and it's going to automate it. So what we're doing here, essentially just adding a single file to the GitHub repository. And if you want, you can click this one, but as I said, I don't recommend that you do that right now. If your package is not very mature yet, not a whole lot of functionality, you can wait later, but the step will be the same. And also you can take a look at the instruction here. If you run into any issues later, once you create a pull request, you can copy this one and then put it in a comment. It's going to add those people, those maintainers, and they will try to help you. And so once everything looks good, you just create a pull request. Like I said, don't do that. I'm going to show you some of the examples that I pull requests that I submitted before, so you can see what kind of things might be needed, or sometimes you might need to make some changes. So I'm going to go to the pull request and go to the authors, and so close. So if you look at this, these are all the packages that I have submitted before that I published. So it's a lot of Python packages, not just my own package, but also you can also put package on conda-forge for other packages. Okay, so some of those, for example, are basically maintained by the community, but I put them on because I want to use that, or some of the packages might be useful for other people. So I also help out. And I can show you, for example, this MedLibre, for example. So this is the package that I help put on there. It's a new Python package, and you can show the step, right? So once you create a pull request, as you can see here, there's not pretty much just the same thing, just the meta.yaml YAML file. So this is basically the recipe used to build the conda-forge package. And it's pretty simple and straightforward, very much similar to what we do for the geohe package, except the dependency might be a little bit different, and there might be some additional dependencies. But in general, the structure is the same, right? We have the home page, you have the docs, and you also have the maintainer who is maintaining the package. And so the first time when it's building, you see here it actually fail. Sometimes if it fails, then you need to, it tells you, okay, the home item is expected. So this is exactly what we did earlier, that we add this home section, because if you don't add it, it's going to fail. And the reason for that is sometimes the maintainer might need to go to the home page to look at what's the functionality of a package. Is it fake, or is it something like not very useful, then sometimes they might not approve your pull request. So once it's done, you see I edit it, and then I edit the home and the doc URL, and then everything is good. Then I can add the conda-forge Python maintenance and just add them saying that the package, the recipe has passed all checks and is ready for review. And after a day or two, you see the maintainer review the package and then approve it. And once it's done, then it's going to basically generate a repo called Fstock. Fstock basically means that it has been added to the conda-forge. And let me show you here under the, not under the Fstock, but you can see from here, right? Fstock. So this is basically every conda-forge package is going to have a Fstock. So that one basically allows you to update the package. So when you initially trying to include the package, it's going to be through here. And so I can show you, for example, MapLibre. And if you search it, you specify this one. So this one only is created after your pull request has been approved and accepted. Then we generate this one. So this is generated automatically, and you will be able to find the recipe under this one. So this repo here is being, if you are the maintainer, if you are the one that submitted the pull request to add this conda-forge package, then it's good, your name is going to show up here. So because the recipe is coming from here, and as you can see, I'm the maintainer of the package. And this is later, if I need to update it, I can again fork the repo, fork this one to my account. So create fork, and then same thing you can do in here, and then create. So later, if there's a new version, this MapLibre package has been released, I can update the recipe. So the recipe means every time you're updating, you will come here, you're going to change this number. For example, it might be 0.1, 0.4. So for example, you're going to update this number, and also you're going to update the SHA to 56. So this one is where basically the hash verifying authentic the file, because every individual file can be used, can generate a SHA-256 hash code. So that means it's not tampered, the file is original. So where do you get this one? It's coming from here. So PyPI, for example, and then I can say MapLibre. I think it's called PyPy MapLibre. No, this one. Okay. Yeah, this is the one. So under the download files, so what you are seeing is from here, view hashes. So this is actually the one. So later, if there's a new version, you're gonna come to the download file, you're gonna see this one, view hashes, and then copy, right? And then you can come back to this one here, and then double click, then just Control V, replace it. And also, if you need to update the package version, you also update in here. And in general, other stuff you don't need to update. So this one, and some of them in here. And once you're done, you can submit a pull request. You need to fork this one to your account and then submit a pull request to the conda-forge Fstock. So you will be able to see from here. And then right click. Then you should be able to update it. Once it's accepted, you're going to show in here. It's going to update, like, for example, v.14, and then that uploads, blah, blah. So this is in general the whole process, how it's being done. I can show you leaf map, for example. So this is also another one that I maintain, and I can show you the pull request. They are locked the pull request. So the bot auto merge, those are actually automatically merged. So conda-forge has the auto merge bot. Robot basically can help you, but sometimes if it doesn't, then you can update manually. For example, this is the one that I updated manually, and you can see the changes, right? So update the version from 0.30.1 to 0.31, and update the hash and also the build number. So anytime if you increase the version, you want to reset the build number to 0. But sometimes if something is missing, you still use the same version, but you can use a different build number. So you can increase the build number to 1. Anyway, those are more like some of the trivial stuff that when you are maintaining the Python package. But if you're new to the conda-forge, you just want to publish the package, then you can just follow the step that I'm showing you here. So let me give you a quick recap. All you need to do is to go to the conda-forge channel here. So let me close all the tabs. And condaforge.org. Then come to here, add a new recipe. Okay, and from this one, you're going to just fork this repo to your account, and then you want to install the Grayscale Python package, and then Grayscale PyPI, name of your package, to generate the recipe, and then put under the directory here within the same basically the stage recipes, and put it under here. Then you push this one to GitHub, then submit a pull request, and once it's accepted, your package is going to appear on conda-forge. And later, if you release a new version, then you can either update the package manually, update the recipe manually, or you can let the robots to automatically update it. But sometimes it might not do everything right. You will need to do some manually changes, but everything should be available here. And like I said, you're welcome to use so for example leaf map to see how I update it manually sometimes, or sometimes let the robot update the package. And once everything is successful, then user can just use conda install. So let me show you here, right? So they can just conda install -c conda-forge, and then the name of the package. So assume that I have this geohe is later is accepted, then I can just install using this way. So it's going to make your package a lot more compatible with other packages, because conda can make sure that all the dependencies compatible with each other in the same environment. Okay, so that's all for this video, and I hope you find it useful. As I said, don't try to submit a pull request. Wait until your package is really ready and mature sometime in the future. Okay, you can then come back to use this video as a reference to publish the Python package. Okay, that's all for this video. I'll see you in the next one. Take care. Bye bye.